Good morning, everyone. So yesterday we wrapped up talking about linear functions and linear equations. So today we're going to review our last unit of 8th grade, which is geometry. And when we started geometry, we started off with transformations. So let's start reviewing transformations. So our topic of today is properties of transformation. Our learning target. Today I can understand properties of transformations by describing the movement of geometric figures. Before we go over any problems, we have to review essential vocabulary. Vocabulary is basically like the meat and potatoes. I sound like Miss Witherspoon. Of geometry. So transformation is a change of position or size of a figure. There are three ways a figure can move from one place to another. There are actually four. Another one we learned is dilation, but for right now we're going over the first three we knew. One, you can slide a figure. You can slide a figure throughout the coordinate plane, left, right, up, or down. Two, you can reflect the figure. You can reflect the figure, meaning you can flip it over. And three, you can rotate the figure, meaning you can turn a figure. These are three types of transformations. Translations moves every point of a figure the same distance and in the same direction. The figure moves left, right, up, and down. Some examples of translations you guys may see in real life is when you're just simply walking around your house. You're just moving left and right, up and down. Well, not really up and down, but you're moving left and right and around your house. Or when you're in the elevator is going up and down. That's a translation. Reflections flips a figure over an imaginary line that can be horizontal, vertical, or slanted. This line is called the line of reflection. An example of reflection you guys may have seen in real life is looking at yourself in the mirror. The line of reflection is the line between you and the mirror. Also, if you look at the examples down here, the right figure was reflected over this horizontal line right here. The right figure was reflected over this vertical line right here. And in this last image, the right figure was reflected over this slanted line right here. In rotations, moves the figures around a fixed point. The fixed point is called the center of rotation. For example, this right figure moved 90 degrees clockwise. And this right figure moved, that doesn't look like 90 degrees. It looks around 45 degrees counterclockwise. Some examples of rotations. Let's see. Oh, clock. So if you look at the hands of a clock, it is moving. It is rotating around the clock each hour and each minute. And the center of the rotation is the little dot that holds the little hand and the big hand. So problem 1, consider the three figures on the grid. How was the green figure transferred to get image A? So the question, part A is asking me is how do I get this green figure to this figure right here? So I know it is not a reflection because it doesn't look like it was reflected. It did not change orientation at all. I know it wasn't a rotation because it doesn't look like it was turned. Again, it didn't change orientation. What I mean by orientation, did not change the position. It does not change the way it looks. So I'm going to assume that it is a translation. I know it's a translation because it moved to the left and it moved down. It moved to the left 1, 2, 3, 4, 5, 6 units. And it moved down 1, 2, 3, 4 units. Part B, how was the green figure transferred to get image B? So the question is asking me, how did I get from this green figure here to this image down here? So I know it's not a translation because this time it actually changed orientation. I know it's not a rotation because it doesn't look like I turned my figure. So I'm going to assume that it was a reflection. Well, I can't show you guys this in person, but if this was on a piece of paper, you can fold the paper in half and you can see that it's the same image. That's another way to prove that is a reflection. So again, I'm going to say that this is a reflection, and it reflected over a horizontal line. All right. Here's your problem 2 of the day. Which transformation can be used to get figure A to figure B? Have a good day, guys. Bye. Oh, okay.